Hi guys, welcome to EdXP. EdXP is an online platform for students to learn and assess themselves outside of the classroom. Today I will cover the topic of integration by substitution technique, which is one of the more challenging topics in the IB analysis and approaches higher level subject. So let's jump right in. So this question over here actually came out last year in the May 2021 Time Zone 2 Paper 1 examinations. So these questions are typically worth 5 to 7 marks. And we can see over here that we have a very complicated integral, also known as a non-elementary integral. And this is an indefinite integral, which means that there should be a constant of integration at the end in our final answer. How I usually approach such questions is to first write the substitution in what I call the right-hand side working. So right-hand working. Okay. You don't have to write that, okay, just for you to know. So the substitution is u is equal to sine x. Okay. And I start by writing the question, the actual question on the left. So we are integrating sine x cos x over a quadratic function sine squared x minus sine x minus 2. The whole idea for integration by substitution is to replace all the x's with u's to simplify the integral. Okay, so a standard move is to differentiate u, first derivative, which gives me cosine x, and I always make dx the subject. So I get dx is equal to du over cosine x. Okay, finding dx is very important so that we can substitute it later on. Okay, so the next step, I will replace everything with u. So sine x is u. If you're not sure what cos x is, you can leave it there first. We have u squared minus u minus 2 at the bottom. And dx, as shown, is du over cos x. We can see that the cos x cancels out. Okay, and we get an expression in terms of u. Okay, the bottom, as we all notice, is a quadratic, so we can factorize it. U minus 2, u plus 1. So immediately you should recognize that this is a proper fraction, no need for long division. And more importantly, we can actually convert this into partial fractions, a topic that was covered in, should have been covered in IB1. Okay, with linear factors, the integral is a over u minus 2 plus b over u plus 1 du. Okay, to find a and b, we can do partial fractions. Maybe let's do a quick one. So u is equal to a times u plus 1 plus b times u minus 2. If you don't understand how I got this, please revise your partial fractions. Okay, to find a and b, we can maybe use a substitution. So when u is 2, what do we have? 2 equals to 3a. Okay, so a is 2/3. When u equals to minus 1, okay, let's use the correct substitution to eliminate the term. Negative 1 is equal to negative 3a. Negative 3b. So b is equal to 1/3. Okay, so we can replace a and b. Let me scroll down a bit. So we can replace a and b. A is 2 over 3. What is b? 1/3. Okay, and you should recognize that this is actually the integral. This is also in the formula sheet. If we're integrating a fraction where the numerator is the derivative of the denominator, it is a ln function, ln mod fx plus c. Okay, so this is an important formula to take note of. Okay, we should recognize that both are going to integrate to ln functions. Okay, so we get 2/3. If I take out the 2/3, I can use the formula in green. Okay, I get ln mod u minus 2 plus 1/3 ln mod u plus 1 plus c, as I mentioned earlier. Okay, and the final step, please do not leave your answers in terms of u. You will have to replace it. Okay, with x's. So it'll be ln sin x minus 2 plus 1/3 ln sin x plus 1 plus c. And that is how you do the question. Okay, I'll move on to the next example. So this question was in the May 2015 time zone 1, paper 1. Same concept, yeah? So we have the substitution u equals to e to the x plus 3. And again, this is a non-elementary integral, so very complicated. We need to use substitution to simplify the expression. Again, we have an indefinite integral, so there's a plus c over here, which should be present in our final answer. Same thing, I will do my right hand working on the right, sorry. So that's u is equal to e to the x plus 3. And I will start writing my actual question on the left. So we're integrating ex over e to the 2x plus 6e to the x plus 13 dx. So the whole idea is to replace our x's with u's. So I need to differentiate u. Always, please do that. So du dx is e to the x, and making dx the subject, I get du over ex. Okay, and we notice that we can actually replace ex with u minus 3. So the whole idea is to change everything from x to u. Okay, so substitution, e to the x becomes u minus 3. And at the bottom, e to the 2x is actually u minus 3 squared. Okay, by the way, e to the 2x is e to the x all squared. Okay, so we're squaring u minus 3 plus 6 times u minus 3 plus 13. Okay, dx I will replace with my substitution du over u minus 3. And we see over here very nicely, u minus 3 cancels out. And we are left with 1 on top. Okay, we can actually start to expand the bottom, so we get u squared minus 6u plus 9 plus 6u minus 18 plus 13. Simplifying, we get 1 over. Okay, so minus 6u plus 6u is gone. We have u squared plus 4 du. And immediately we should recognize that this integrates into a up trigo function. In particular, the integral of 1 over a squared plus x squared. So this is in your formula sheet. Gives me 1 over a up tangent x over a plus c. Okay, so this formula, there are 2 more, one for arc sine and one for arc cos. So please know them well. Okay, and this integrates to 1 over, so using the formula, 1 over 2 arc tangent u over 2 plus c. Okay, and of course, don't leave your answer in terms of u. We have to put it back to x. Here's the original question. So the final answer is half arc tangent u is ex plus 3 over 2 plus c. And that is the final answer. Okay, I hope you guys got that so far. I'll move on to my final question before we go into some of our EdXP questions. So this last example came from the May 2017 time zone 2 paper 1. We can see over here that the substitution is x equals to tangent theta. Okay, and I want to show that something on the left is equal to something on the right. Okay, so I'm going to stick to that discipline. What I usually do is I put left hand side is equal to this integral over here. And I want to prove it step by step to the right-hand side. Same procedure, I will do the right-hand side working. What is my substitution? Always put your substitution on the right-hand side. So the x equals to tangent theta. Okay, differentiating dx by d theta, we should all know by now, is secant squared theta. Okay, so I like to make dx the subject so that I can substitute it later on. Just bring the d theta over. And notice that in this question is different from the previous two questions. This is a definite integral. So we have the lower limit as 0 and upper limit as 1. I want to change my x limits to theta as well. Okay, so when x is 0, what is theta? Okay, from special angles or from the graph, we know that when x is 0, tangent 0 is also 0. Okay, so when x is 0, theta is 0. When x is 1, what is theta? Okay, from your special angles, you should know that theta is pi over 4. Okay, so tangent 45 degrees is 1. So notice for definite integrals, we want to change our limits as well from x to theta. Okay, we have all the information there. So I can attempt to substitute my x's to theta. 0 remains as 0. Okay, so when x is 0, theta is 0. When x is 1, theta is pi over 4. Okay. X is tangent squared theta plus 1 squared. Okay, this is very familiar. Okay, you should know this is a trigo identity. And dx, I want to replace with secant squared theta d theta, as I have shown on my right-hand side. Okay, this simplifies to secant squared theta over, okay, tangent squared theta plus 1, trigo identity is actually secant squared theta. Okay, so we get secant 4 theta over here. Okay, and this simplifies to 1 over secant squared theta, which is actually cos squared theta. Okay, and there we have our right-hand side. Okay, it would be nice to put a bracket shown. And that is for part A. Okay, let's move on to part B. I want to evaluate this. So this question is quite nice. It kind of breaks it up into two different parts for us. Takes us step by step. So for part B, we know that part B is similar to my right-hand side in part A. So what I'm actually doing is I'm actually integrating cos squared theta d theta. Okay, please note at this point, okay, we cannot integrate trigo functions with higher powers, okay, high powers. We cannot use simple anti-differentiation. So a common mistake is to add 1 to the power, divide by new power, yeah? But what we have to do here is actually to use double angle formula to reduce the power of the function. Okay, so I'm looking at, let me write it down. Cos 2 theta is cos squared theta, 2 cos squared theta minus 1. Okay, this is one of the double angle formulas. Okay, so this means that cos squared theta is actually cos 2 theta plus 1 over 2. Okay, so this is a double angle conversion. And we can actually take out the half if we want. Okay, and we can integrate straight away. Cos 2 theta using basic difference integration is integrating cos, we get sine. Okay, angle remains the same, but we divide by the differential of the angle. Okay, integrating 1, we have theta. After integrating, please put your limits 0 to pi over 4, and then we can substitute top limit minus bottom limit. So sine 90 degrees is 1 over 2 plus pi over 4. Okay, and my lower limit gives me 0. Sine 0 is 0, theta is also 0. So the final answer is 1/4 plus pi over 8. Okay, no plus c this time because this is a definite integral. Okay, so I hope you guys understand this concept. The past 3 questions were from the actual IB past papers, okay, paper 1. Let's move on to some of our own EdXP questions. You can go online and practice. Okay, so this is a integration by substitution question. Same concept. Substitution given is u equals e to the x. Okay, let's zoom in a bit. We have 4 MCQs here, but let's try to work this out first. Okay, same concept. Right hand working, put my substitution in. This is a indefinite integral, so there will be a plus c in our final answer. Okay, as usual, I will find du dx, which is also e to the x. And again, I also like to have the habit of making dx the subject. Okay, so in this case, dx is du over u. Okay, and that's that. Let's try to solve this. So the idea with integration by substitution is to replace all the x's with u's. 16, maybe I can take it out, it's just a constant. Okay, I have u over square root 3 minus u squared. And dx is du over u. And the u's top bottom, they cancel. So I get this expression, which you should immediately recognize to be a arcsine function. Okay, let me write out the formula. So this is in your formula sheet. Okay, so the integral of 1 over square root a squared plus x squared is arcsine x over a plus c. Okay, so please remember that. You should be familiar and be able to recognize that this is a arcsine function. Okay, so we get 16 arcsine u over root 3 plus c. Okay, and never leave your answer in u, put it back in x. So we have 16 arcsine x is u is e to the x over root 3 plus c. Okay, so let me zoom out. I believe the answer is A. Okay, I will do one more question from our EdXP database. So this is another question, integration by substitution. Let me zoom in so that we can have some space. Substitution is a few things to recognize. Yeah, substitution is u equals e to the x. So we're going to use that. And this is a indefinite integral. So there will be a plus c at the end in our final answer. Right hand working, substitution is u equals e to the x. So we follow this procedure. Differentiating, we get e to the x, which is also u. Okay, and I like to make dx the subject. So there's du over u. Okay, no limits to change, so let's leave it as it is. Let's go straight in. 5, maybe I can take it out, it's just a constant. 1 over 2 over u, okay. E to the minus x is reciprocal, 1 over u, plus u, and dx is du over u. Okay, and let's simplify our fraction here. It's 1 over 2 plus u squared over u, du over u. Okay, and we can actually flip this up, u over 2 plus u squared du over u. Okay, so the u's cancel out. Immediately, you should recognize that this is a, this is a arctangent function. Okay, so we have 2 plus u squared. The formula, let me write it down in your formula sheet, is if we integrate 1 over a squared plus a squared plus x squared, dx is 1 over a arctangent x over a plus c. So this is in your formula sheet. Okay, you should be able to recognize it immediately when you simplify. Okay, so the final answer will be 5 over root 2 arctangent u over root 2 plus c. Okay, and don't forget to replace your u's with x. So the final answer is 5 over root 2 arctangent ex over 2 plus c. Okay, so the final answer is here, which I believe is A, option A. Yes, so I hope everyone has learned something from this video on integration by substitution. Feel free to go to our EdXP platform to practice on some of these techniques for this topic. Thank you.